Does calibration improve rock score? I'm studying the effects of performing a calibrated classifier, and I read that the aim of calibrating is to make a classifier's prediction more reliable. With this in mind, I think that a calibrated classifier would have a higher score, rock_awk. When testing this hypothesis in Python with scikit-learn, I found the exact opposite. Could you please explain? Does calibration improve rock score? Or any metric? If it is not true, what is / the advantage /s of performing calibration?
TLDR, calibration should not affect rock. Longer answer. Rock is a measure of rank. Did we put these observations in the best possible order? However, it does not ensure good probabilities. Example, if I'm classifying how likely someone is to have cancer, I may always say a number between 95% and 99%, and still have perfect rock, as long as I've made my predictions in the right order. The 99% S had cancer, the 95% S did not. Here we would say that this classifier, that says 95% when then are unlikely to have cancer, has good ability to rank, but is badly calibrated. So what can we do? We can apply a monotonic transformation that fixes it without changing the rank ability, therefore not changing the rock. Example, in our cancer example we can say the predictions are under 97.5%, they should be decreased by 90%, and when they are over 97.5% they would be kept. This really crass approach will not affect the rock, but would send the lowest predictions to close to zero, improving our calibration, as measured by the Brier score. Great, now we can get clever. What is the best monotonic curve for improving our Brier score? Well, we can let Python deal with this by using scikit's calibration, which essentially finds that curve for us. Again, it will improve the calibration, but not change the rock, as the rank order is maintained. Great, so the rock does not move. And yet, to quote Galileo after admitting that the Earth does not move around the Sun, "E pure si muove," and yet it moves. Okay, now things get funky. In order to do the monotonic transformations, some observations which were close, for example 25% and 25.5%, may get squished together, for example 0.7% and 0.700000001%. This may be rounded, causing the predictions to become tied. And then, when we calculate rock, it will have moved. However, for all practical purposes, you can expect that the real rock does not get affected by calibration, and that it should simply affect your ability to measure probabilities, as measured by Brier score.
If you would support the channel, please consider subscribing.